In this video here, we're going to take a look at modelling with differential equations. Now we can model real life situations by using differential equations. And before continuing with this video here, just make sure that you're confident with the material for differential equations from A-Level Maths and Core Pure, as well as the previous material from this chapter covering reducible first order and second order differential equations. So in terms of an introduction here, we don't need too much, right? We are just covering everything that we've seen in this chapter here and the stuff for differential equations from A-Level Maths and Core Pure. Okay, so that concludes this introduction here to modelling with differential equations. Let's just work through a practice question together. So let's just have a go then at this one practice question here. So as we can see then for this question here, we have a particle that is travelling along the x-axis and its displacement x at time t seconds is given by this differential equation here. Let's just start then by calling this differential equation here equation 1. And then for the first part of the question, part A, pretty standard stuff here. All it wants us to do then is use this substitution here, x equals ut, to transform equation 1, this differential equation here, into this differential equation here. So let's just call this one then equation 2. Okay, so for the first part of this question here then, part A, let's just begin here then with this substitution. So x equals ut. Okay, now if we want to transform equation 1, that's this differential equation here, what we do need is dx by dt, right? Some expression for dx by dt. So if I've got x equals ut here, what I need to do then is differentiate x with respect to t. So in that case, then we get dx by dt here. And for dx by dt then, I'm hoping it's kind of obvious here, but we do need to use the product rule, right? We have a product of functions. So again, hopefully pretty trivial at this point. By the product rule then, what we get here is du by dt times by t, I'll put the t here on that side, plus u. Okay, so we get t du by dt plus u. Okay, and now that we have dx by dt then, what we can now do here is transform equation 1, hopefully, into equation 2. So if we go to equation 1 then, all we need to do here is substitute where appropriate. So to begin with, we have tx here, so that's t, times by x where x equals ut. Okay, so I've got t times ut. We then times this by dx by dt here. So dx by dt, as we've just obtained here, is t times du by dt plus u. Okay, so let's just jot that down here. So t du by dt plus u. Okay, we then have minus x squared here, where x equals ut. So minus then ut squared. And this here then is all equal to 5t to the 4. Okay, so what we need to do now is basically just expand and simplify. And hopefully then what we obtain here is equation 2. So to begin with then, we have t times ut, so that's ut squared. So I've got ut squared. I won't expand this here just yet with this bracket. So let me just write this bracket out again here. So that's t times du by dt plus u, like so. Now, ut squared here, so that's ut all squared, that gives us minus u squared t squared, and this here then is equal to 5t to the 4. Okay, so now let's expand out here then, this term here on the outside, this ut squared, with the two terms inside this bracket. So the easier of the two terms here is just the u, right? So ut squared times u, that gives me u squared t squared. But just notice here then, we have this minus u squared t squared. So if we have u squared t squared minus u squared t squared, they just cancel, like so. And now then, if we expand ut squared with t du by dt, what that gives us then is u t cubed du by dt. Okay? And this here then is all equal to 5t to the 4. And at this point here, we're getting pretty close to the required solution, right? The required differential equation. So at this point here then, let's just divide both sides by t cubed. So what I got on the left-hand side here, nice and straightforward, is simply u du by dt. So u du by dt, and that is all equal to 5t. Okay? And as you can see here then, u du by dt is equal to 5t is exactly what we wanted to obtain here. So as required then, and there we have it. So as required there, and that gives us the solution to the first part of this question anyway, part A. So now then, let's have a go here at part B. So for part B then, let's just do this directly underneath here. We're given that x equals 4 after 2 seconds. So after 2 seconds then, all that's just telling us here then is t is equal to 2. Okay? So what we want to do here then is show that the particular solution to the differential equation here, that's equation 2, can be expressed as follows. So all we need to do here then is just basically solve this differential equation here, equation 2, right? And hopefully by inspection, it's pretty obvious that all we need to do here then is just separate the variables, right? Nothing too challenging. We don't need an integrating factor or anything like that. All we need to do here then is just separate the variables and integrate both sides. Okay? So on the left-hand side here, anything in terms of u, and on the right-hand side here then, anything in terms of t. So on the left-hand side then, what we get here is u du. So I get u du on the left-hand side. And then on the right-hand side here, we get 5t dt. Okay? So I get 5t dt. And as I've just mentioned here then, to solve this differential equation, all I need to do now is just integrate both sides here. I've got the integral then of u du is equal to the integral of 5t dt. Okay? Pretty straightforward here then. Just add 1 to the power, divide by the new power, so I get u squared. So u squared over 2 is equal to, so on the right-hand side here then, what do we get? So I get 5t squared over 2 plus c. So 5t squared over 2 plus c. Okay? Well, let's just times through by 2 here. So if we times through by 2 then, what I get here, in fact, before I times through by 2, don't forget that I do also need to find c here. So I'm kind of jumping ahead of myself here. Don't forget c. So for c then, what we need to do here then is use this boundary condition here. Okay, so x equals 4 after 2 seconds. So what I've got here is x equals 4 and t equals 2. Okay, and we know then, based on this substitution here, x is equal to ut. Okay, so let's just rearrange here then for u. So u here, so u is equal to x over t. Well, x is 4, as we can see here. T is 2, so I get 4 over 2, which is 2. Okay, so what I've got here then is u squared over 2 is equal to 5t squared over 2 plus 2. So my c here is 2, right? So if we times through by 2 then, what I get here is u squared is equal to 5t squared plus 4, right? 2 times 2 gives us 4. Now, at this point here, we've got u squared is equal to 5t squared plus 4. But we know then that u here is x over t. So what I can do then is replace u squared with x squared over t squared. Just squaring both sides here then. So what we've got here then is x squared over t squared, like so. And that is equal to 5t squared. So 5t squared plus 4. Okay. And we're getting pretty close to the particular solution here. That's the solution that we want to obtain. So what I'm going to do next here is times through by t squared. So if I do that over here then, what do we get? So x squared is equal to, so I get 5t squared times t squared, so that's 5t to the 4. So I get 5t to the 4 there. I then get 4t squared, right? So 4 times by t squared, that gives us plus 4t squared. Okay? Well, what I can do here then is factor out a t squared. So I've got t squared times 5t squared plus 4. So kind of reflecting on my working here, it might have just been easier to write the multiplication as that anyway, but it doesn't really matter too much. And then at this point here, so this is x squared. So that is x squared here. If I just want x here, then all I need to do is just take the square root of both sides here. And let me just do that over here then. I'm going to room a little bit here. In that case then, x here is equal to, so the square root of t squared is just t. I get t times by the square root then of, I've got 5t squared plus 4. So 5t squared plus 4 there. And just notice then, this is exactly what we wanted here. So again, as required. So as required there. And there we have it. So that gives us the solution to part B of this question. And then finally, we have part C here. So for part C then, let me just quickly clear the screen here. We don't really need any of the previous working to answer, part C. So for part C then, it just says here, state what happens to the displacement as t becomes large. So hopefully it's kind of obvious here. But in this question here, the displacement will increase without limit. So all we need to say here then is the displacement here increases without limit. Increases without limit. Okay. In other words, it's just going to become very large. Okay. So the displacement here, x, so x will become very large. Okay. Just something along those lines there is absolutely fine. Okay. And there we have it. So that gives the solution to the very last part of this question, part C. And that actually brings the end then of this video here on modeling with differential equations.